Hey guys, this is Miss Garner, and this video will help you complete the Pythagorean Theorem number 1 assignment. The first week we have started our new unit. So this first page here is just a quick review from the square and cube roots that we started last week. And the main thing here that you need to keep in mind is that we're going to be using inverse operations. All this means is opposite. So just like addition and subtraction are opposites, and multiplication and division are opposites, a square and a square root are inverse operations, and a cube root are inverse operations. So when you see a problem like this, in order to get x simplified, we want to do the inverse. So number one is x squared equals 25. I see the square, so I'm going to do the square root. So x equals the square root of 25, which is 5. Number two is the square root of x equals 7. Once again, I see there's a square root, so I'm going to do the opposite, which is what we call the inverse. So I'm going to square both sides. Remember, if you square both sides, that's how this goes away. So x equals 7 squared, which remember is just 7 times 7. So x equals 49. Number 3 is x cubed. So remember, cube is just to a power of 3. X cubed equals 8. So the opposite of a cube is a cube root. So I'm going to take the cube root of 8, which is 2. So x equals 2. And then our last one is the cube root of x equals 4. So the opposite of this is to take the cube. So 4 to the third power, x equals 64. We can always check our answers. So remember, you can always plug in your answer for x to see that it's correct. So our first one here, if I plug that 5 in for x, I get 5 squared equals 25. And we know that's correct, right? 5 squared is 5 times 5. I know that equals 25, so I know that's correct. So once again, what you need to get away from this is that a square and a square root are inverse, and a cube root are inverse, just like addition and subtraction are. This new unit is the Pythagorean Theorem. The theorem itself is here at the bottom. A squared plus b squared equals c squared. This theorem is used with only right triangles. And the way that we're going to use this is we're going to use it to find the side length, find the length of a missing side in a right triangle. So a couple of vocabulary words you got to know. The first one is leg. So we call a leg the two sides of the triangle that create your right angle. So in our picture down here, here's our right angle. You see that box there. A right angle is just a 90-degree angle. So the two sides here, A and B, are the two sides that come together to form that right angle. So those are what we call the two legs. It doesn't matter which one is A, which one is B. Those can be switched. The side opposite of that right angle, so if you go opposite, the longest side on this triangle is C. That is your hypotenuse. So your theorem says side length A squared plus side length B squared equals your hypotenuse squared. What that actually means is if we're actually going to draw a square, right? If we look at this picture here on the left, this is side length A. Well, if I make that a square, right, all side lengths are the exact same. The area of that small squared is A times A, which is A squared. Here's side B. Once again, if I draw that square, the area of it is B times B, which I can simplify as B squared. And same thing with this last side, C. All my side lengths here are C, which means my area is going to be C times C, which is C squared. So what our theorem is saying, A squared plus B squared equals C squared, is that the area of the small square plus the area of the medium square adds up and equals the area of the large square. So you can see down here in the right, we have an example with actual numbers. This side length here is a side length of 3. So when we draw out that square, you see that that's 9 units big. This side length of 4, when we draw out its square, we see that it's 16 units big. And then our hypotenuse, 5, when we draw out the square here, you will see that it's 25 units big. So the area of the small square, which is 9, plus the area of the medium square, which is 16, when you add those together, notice that it equals the area of the large square. That is all our theorem is telling us. So a squared plus b squared equals c squared. So here's an example of how we're actually going to use this. So I'm going to write the theorem up at the top again. A squared plus b squared equals c squared. If I look at my triangle now, I need to figure out what these side lengths are. So here's my right angle, and you see that these two sides that create it, those are going to be my two legs. So I want to label 3 and 4 as A and B. Doesn't matter which one is which. So I'm just going to say A equals 3 and B equals 4. But like I said, you could switch those, right? You could have B where A is and you have A where the B is. That doesn't really matter. That means the side length that we are missing is the side that's opposite. That's our hypotenuse, and that is always going to be labeled with the C. So what we're actually trying to look for is C. What is the length of side C? In my equation, I know what A and B are. These two values here, I can plug in with these numbers, which I know the problem has given me. So A squared, I can write as 3 squared. B squared, I can write as 4 squared. And C squared, I'm going to keep that as a C because I don't know what that is. It's going to have to stay a variable. Once I've done this, I'm just going to simplify. So I'm just going to figure out what is 3 squared. That's just 3 times 3. So that's going to be 9. 4 squared is 4 times 4. So this is 16. And remember, once again, you can always use that calculator, the Web 2.0 calculator. And this is still going to equal C squared. Once I've squared both of those, I'm just going to add them together. So 9 plus 16 equals 25. And you'll see that this last step looks very similar to those review problems we just did. 25 equals c squared. This is where we're going to use that inverse operation. The opposite of a square is to take a square root. Because when I take the square root on the right-hand side, that square root and the square, that goes away to leave us with just c, which is what we want. That's what we're trying to solve for. What is c? So c equals the square root of 25. Once again, you can do that in that calculator, or if you know it in your head, that gives you c equals 5. One thing you can do to help check your answer is that hypotenuse is always going to be the longest side. So one thing we can check is making sure that's longer than the two legs, which it is. So our answer here is c equals 5. One more example here. Our theorem, once again, Pythagorean Theorem, says a squared plus b squared equals c squared. If I look at my triangle, I see that the two sides that they have given me are my two legs. They're the two sides that form my right angle, the one that has the box there. So it doesn't matter which one is which. I'm going to go ahead and say A equals 6, B equals 10, but it doesn't matter which one you label as which. That means the one side that is missing, so notice that this side doesn't have a number on it, that's going to be your hypotenuse, that's C. That is what we're trying to find. This whole first week, guys, you are always going to be finding that hypotenuse. Moving forward, though, sometimes you'll be finding the leg instead. So when solving the problem, you're now going to plug in the 6 and the 10 for your A and your B. So you're going to get 6 squared plus 10 squared equals C squared. So remember, that stays a variable, that stays C, because we don't know what it is yet. That's what we're trying to find. Now simplify. So 6 squared equals 36. 10 squared equals 100. And that's still going to be equaling C squared on your right-hand side. I'm going to add these two numbers together, so 36 plus 100, so 136 equals C squared. And then remember, that last step is to do the inverse. So the opposite or the inverse of a square is to take the square root. So I'm going to take the square root of 136, and I get C equals, and this is one I need to do on the calculator, so the square root of 136 equals 11 point, and then a huge long decimal. So remember, you can always stop after the thousandths place. So you can stop after 3 numbers after the decimal. So 11.661. So that is the length of side C. That is what we were trying to solve for. So that's our answer. C equals 11.661. So with these problems using Pythagorean theorem to solve for your hypotenuse, you're going to take the square of both your legs, add it together, and then whatever number you get, your last step is to take the square root.